My name is Geoffrey Bastard, Regional Technical Specialist with Certis. We're here today at Harper University visiting Professor Keith Walters of Invertebrate Biology at the Entomology Department. The uncertainty around the long-term future of metaldehyde has seen a large uptake in the use of ferric phosphate slug pellets, now a very viable alternative molluscicide to metaldehyde. With metaldehyde, growers are used to seeing dead slugs and slime trails on the soil surface. And we often get the comments from growers, what happens to the slugs who ingest ferric phosphate? Where do they go in the soil profile and what's happening to them? This is something Certis is working on with Professor Keith Walters.
The slugs spend a large proportion of their lives under the soil surface. And so when you're trying to look at how they move and how they disperse around a field, it becomes very difficult because you can't see what they're doing. They're underground. We came up with the idea that if we used RFID tags, radio frequency identification tags, the kind of thing you put in your cat and or your dog at the vets in order to identify it if it gets lost, if we put those into slugs, then we could track them using an antenna as they're under the soil without having to dig them up. Tagging the slugs has to be done very, very carefully. There's an ethical dimension. We don't want to do anything which will hurt the animal, and certainly wouldn't countenance that. But equally, we need to make sure that it's done in such a way that the behaviour of the slug is left completely unaffected by the presence of the tag. The experiment which we did is in its concept relatively simple. We went out to a real commercial field and caught a large number of grey field slugs, which we then returned to the laboratory and left for a few days to acclimate to the laboratory conditions. After that time, the slugs were divided into 6 groups. When we had enough slugs, we would release them then 5 at a time into these containers. These had contained a layer of soil which was taken from the commercial field we'd originally got the slugs from, but also we had an airspace above them. So what did we find? Well, the results were remarkably clear. Starting with those slugs which hadn't eaten any ferric phosphate, they seemed to behave quite normally according to what we know they do in the field. They would go periodically below the soil surface to hide from predators, and then they would come to the soil surface at regular intervals in order to feed. To all intents and purposes, they didn't know they were in a tank. They were just behaving as they normally do in a farmer's crop. The groups of slugs that ate the ferric phosphate, however, behaved very differently. Whether we pre-fed them with the pellets or whether we offered them the pellets in the tank didn't matter. What they did was to retreat eventually below the soil surface. What do I mean by eventually? Well, for the first 3 hours where we looked at them intensively, to all intents and purposes, they didn't seem to differ from the other treatments which hadn't had ferric phosphate. But thereafter, they began to start moving quite rapidly below the surface and didn't come back up again. So when we looked after the first day, we found quite a reasonably large proportion, about 50 or 60% of the slugs overall, were below the soil surface. And that proportion increased until virtually every slug was below the soil surface by about 2 to 3 days after we'd fed them with the pellets. At the end of the experiment, when we had taken all these recordings, we actually dug out every last slug that we'd found from every treatment, and we found that there was very, very, very high mortality of the ferric phosphate slug pellets. They had simply eaten the slug pellets, retreated beneath the soil surface, presumably to protect themselves from dehydration if they got caught out in the sun, or take themselves out of the way of predators, and then they had stayed where they were, didn't move, and died.